Emission is the process where a substance gives off or emits radiation upon heating or chemical treatment or by some external stimulus. The quantum effect causing the spontaneous decay of excited states of atoms or ions is called spontaneous emission. The level of emission of a substance depends on its spectroscopic composition and temperature, property of the atoms, and by the mode structure, that is, vibrational pattern of the surrounding medium. Light produced by spontaneous emission is called luminescence. When an atom or a laser ion in a gain medium is excited into a higher lying energy level, for example, by absorption of a photon, it may after some time spontaneously return to its ground state or to some intermediate energy level by releasing the energy in the form of a photon or at times form of phonon, which carries the energy in some specific random direction. More precisely, the photon can correspond to any propagation mode of the mediums surrounding the atom or ion. The process is called spontaneous emission and it has no external stimulus that is needed. Stimulated emission is the process by which an incoming photon of a specific frequency can interact with an excited atomic electron or other excited molecular states, causing it to drop to a lower energy level. This is in contrast to spontaneous emission, which occurs at random intervals without regard of the ambient electromagnetic field. If an electron is already in an excited state, an upper energy level in contrast to its lowest possible level or ground state, then an incoming photon for which the quantum energy is equal to the energy difference between its present level and a lower level can stimulate a transition to the lower level, producing a second photon of the same energy. The liberated energy transfers to the EM field and it creates a new photon with the phase, frequency, polarization, and direction of travel that are all identical to the primary photon of the incident wave. Stimulated emission requires, like absorption and spontaneous emission, that the photon energy given by Planck's relationship be equal to the energy separation of the participating pair of quantum energy states.